Welcome to the second video in our series, Getting Started with Python on Windows 11. In the first video, we used winget to install and manage software from the command line. In this video, we'll take the next step, creating a project folder, setting up a virtual environment, and installing Python packages using pip. If you've ever heard someone say, "It works on my machine, but not yours," virtual environments are how we solve that problem. They give each project its own isolated set of packages, so nothing conflicts and everything stays reproducible. Let's open Windows Terminal. You can press the Windows key and type Terminal, or right-click on the Start button and select Terminal. Before we begin, let's make sure Python is installed. If you follow along with the first video, you may need to reinstall Python 3.13. Let's do that now. If Python is already installed, winget will let you know. Either way, let's confirm it's available. Simply typing Python -- version. So great, Python 3.13 is ready to go. So now let's set up our first project. Every Python project should live in its own folder. This keeps your files organized and, as we'll see in a moment, allows each project to have its own set of packages. Let's navigate to the Documents folder and create a new project directory. You'll want to adapt these paths to match your own username. We'll now create a folder for our project. And now navigate to it. Learning to navigate with the terminal is a valuable skill. If you're used to File Explorer, this might feel unfamiliar at first, but modern terminals offer tab completion that makes typing long path names much easier. We now have an empty project folder, so next let's create a virtual environment inside it. When we installed Python, it came with a minimal set of features, really just the interpreter and pip, the package manager. To do anything useful, we need to install additional packages like numpy, pandas, or matplotlib. But here's the key idea. Instead of installing packages into our system-wide Python installation, we create a virtual environment for each project. This way, each project gets exactly the packages it needs, nothing more, nothing less. So why does this matter? A few reasons. First, different projects might need different versions of the same package. Second, keeping environments separate makes it easy to share your setup with someone else. And third, it avoids cluttering your base Python installation with dozens of packages you might not need everywhere. Python includes a built-in module called venv for creating virtual environments. So let's use it now. We simply type Python -m venv.venv. This command tells Python to run the venv module and create a virtual environment in a folder called .venv. And this is inside our project directory. The dot prefix is a common convention. Many development tools like VS Code and PyCharm will automatically detect a .venv folder and configure themselves to use it. It also keeps your project directory looking clean, since dot prefixed folders are often treated as hidden or configuration files. So let's take a quick look at what was created. You can see several folders here. The important ones are scripts, which contains the Python interpreter and activation scripts, and the lib folder, where packages will be installed. This is a self-contained copy of Python that belongs only to this project. Before we can use our virtual environment, we need to activate it. Activation tells the terminal to use the Python interpreter and packages inside the .venv folder instead of the system-wide installation. Since I'm using PowerShell, I'll type the following. Notice that the prompt changed, and now we see .venv inside parentheses at the beginning of the command line. This is your visual confirmation that the virtual environment is active. So any Python commands you run and any packages you install will now apply only to this environment. If you're using the classic command prompt instead of PowerShell, the activation command is slightly different. Either way, you'll see the same .venv inside parentheses as an indicator. Let's verify we're working with a clean environment by checking what packages are installed. We do this with pip list. We can see that pip is the only thing installed. So this is a completely clean starting point. And this is exactly what we want. Every package we install from here will be specific to this project. With our environment active, let's install some packages. Pip is Python's package manager, and it works similarly to how winget works for Windows software. The command is pip install, followed by the package name. Let's start with numpy, which is the foundational package for numerical computing in Python. We simply type pip install numpy. Pip downloads numpy from the Python package index, also known as pypy, and installs it into our virtual environment. You can see the download progress and the confirmation that numpy was successfully installed. Now, let's install pandas, the most popular package for working with tabular data. Again, we type pip install pandas. You may notice something interesting here. We asked for pandas, but pip also installed several additional packages. Things like Python dateutil, pytz, etc. These are dependencies, packages that pandas relies on to function. So pip is handling all this automatically, which is one of its most useful features. After it's complete, let's check our environment now using pip list. We can see numpy, pandas, and all their dependencies. Everything is neatly contained within our virtual environment. If you receive a notice to upgrade pip, you can do that as well. This would be done with python-m pip install --upgrade pip. And it's good practice to keep pip itself up to date. I'm going to install 3 more packages, polars, matplotlib, and plotnine. I'll speed through these installations, but the command is the same pattern each time. We use pip install followed by the package name. With all 5 packages installed, let's see the complete list. Again, we simply type pip list. We started with just pip, and now we have a comprehensive set of tools for data analysis and visualization. You'll notice the list is quite a bit longer than 5 packages, and that's because all the dependencies that were automatically pulled in, and this is completely normal. Before we wrap up, there's one more important command. You can save a snapshot of your environment to a file called requirements.txt, and we do this using pip freeze. we type pip freeze, the redirect operator, which is the greater than symbol, and then requirements.txt. The greater than symbol here, as I mentioned, is called the redirect operator. It takes the output from pip freeze and then writes it into the file requirements.txt. This file captures every package and its exact version number. It's an invaluable tool for sharing your project, and anyone can recreate your exact environment by running pip install-r requirements.txt. Let's take a quick look at what it created. We can use cat and then .requirements.txt, and this will show the contents of the file. Again, every package is pinned to a specific version, and this is how you make your work reproducible. When you're finished working in your virtual environment, you can deactivate it by simply typing deactivate. Notice that the .venv inside parentheses has disappeared from the prompt, and you're now back to using the system-wide Python installation. The virtual environment and all its packages are still there in the .venv folder, so nothing is lost. The next time you want to work on this project, just navigate back to this project folder and run the activation command again. Let's recap what we covered. We created a project folder, set up an isolated virtual environment using Python's built-in venv module, activated it, installed packages using pip, saved our environment to a requirements file, and then deactivated the environment when we were done. In the next video, we'll install Jupyter Lab and actually start writing Python code. That's where everything we set comes together. So check out the complete series on getting started with Python in Windows 11.